Welcome to EDU World Space.
Hello and welcome to Chapter 1, Problem number 21 in Physics for Scientists and Engineers with Modern Physics. So this problem asks us to calculate the radius of a sphere of aluminum given that it has the same mass of a sphere of iron. And it also, in the beginning of this problem, tells us some preliminary information about iron and aluminum. Specifically, it tells us essentially their densities, because we have a cubic meter of both aluminum and iron with a mass. And as we know, density is your mass divided by your volume, but in each case, we have a volume of 1. So those numbers that are given to us are, in fact, the densities of aluminum and iron that we'll be working with. So I also have the equation for the volume of a sphere over here to the right. This is very important for this problem because the radius is what we're being concerned with anyway. So to start things off, we're going to be finding the mass of this iron sphere. So it tells us at the end of the question that the radius of this iron sphere is 2 centimeters, or 2 times 10 to the minus 2 meters. So what we're going to do is we're going to plug that R value into our volume equation, and then use our known density to find the mass of that sphere. So we do the volume of our iron sphere is 4/3 pi times that radius, 2 to the negative 10, or sorry, 2 to the negative 2 cubed. So we'll get a volume for that iron sphere of 3.35 times 10 to the minus 5 cubic meters. So now we have that. We need to rearrange our density formula to solve for mass. And then we'll see I have the density of the actual substance multiplied by the volume of that substance. So we have our volume here that we just calculated, and we also have the density of the iron given to us in the very beginning. That's 7.86 times 10 to the minus to the regular third. So what we need to do is multiply these two values together, and we'll get about 0.263 kilograms. So what we need to say next, now that we have the mass of our iron sphere, is equate that to the mass of our aluminum sphere, because that's what. Oh, sorry about the scrolling. Because this is what's gonna keep them balanced on a scale like the problem suggests. So we can say that the mass of the aluminum is also 0.263 kilograms. And doing that, it's just a matter of working backwards from what we did to get to this point. So we need to rearrange our density equation, and we have volume is equal to mass over density. So we take the mass that we have calculated here, and then we divide by our density of the aluminum, so that 2.7 times 10 to the third. So that'll give us a volume, total volume of this aluminum sphere is 9.755 times 10 to the minus 5th cubic meters. And so now what we need to do is use our the volume equation that we did. We need to rearrange for our radius. I skipped a little bit of steps here. It might be a little bit hard to follow, so just bear with me for a second. So solving for our R in our volume equation here, we need to divide our total volume that we have calculated right up top here. We need to divide that volume by 4/3 times pi, or 4 pi over 3, whatever. And then we need to take the cubic root, or another way of writing cubic root is as I've done here, as an exponent 1 over 3. It doesn't really matter how you want to write it, but the math is the same. So in the end, what we'll be doing is we'll taking that 9.755 times 10 to the minus 5th. We'll divide that by 4 pi on 3, and then we'll take the cubic root of that quantity. And in the end, we'll get 2.86 times 10 to the minus 2 meters, or 2.86 centimeters.